All right, so for questions 1 through 12, you need to really have a good idea and understanding of lines. So we need to recall that slope equals y2 minus y1 over x2 minus x1. We have y equals mx plus b, so that's your slope-intercept form. We're going to be using point slope a ton. If two lines are parallel, then the slope is the same. If two lines are perpendicular, then the slopes are opposite, reciprocals. If a line is horizontal, then your slope is 0. If a line is vertical, then the slope is undefined. If your slope is 0, you have y equals. If it's undefined, you have x equals. So that pretty much wraps up 1-1, which is lines. One 1.2 is about graphs. You want to know if they're even, odd, or neither, domain, range, functions, etc. So the second part of the review said to determine whether the function is symmetric, about the origin, y-axis, or neither. So in order to do that, you would just kind of give yourself a quick sketch. So something like x to the 1/5. Well, the 1/5 power is going to make it odd. Therefore, it's the origin. To algebraically determine whether it's even, odd, or neither, such as example 19, you have y equals x squared plus 1. So what you're supposed to do is plug in a negative x. So you'd have negative x squared plus 1. Simplify. That leaves you with x squared plus 1. So when you simplify, if you get back the original, that makes this even. Something like 23, where you have y equals x to the 4th plus 1 over x cubed minus 2x. Once again, plugging in the negative x, you get negative x to the 4th plus 1 all over negative x cubed minus 2 times negative x. Simplifying, that gives x to the 4th plus 1. And then down in the denominator, you get negative x cubed plus 2x. Well, in the denominator, I could factor out a negative 1, and that leaves x cubed minus 2x. And x to the 4th plus 1. Well, if you can factor out a negative 1, that makes this odd. Okay? And then to determine domain, range, and graph, it's important to know exactly kind of what those graphs are. So if you have something like an absolute value, the domain of an absolute value is all reals. The range in standard form is greater than or equal to 0. So in something like 27, where you have y equals the absolute value of x minus 2, your domain stays all reals, but the negative 2 shifts your graph down to. So that graph getting shifted down 2 changes your range to be greater than or equal to -2. Y equaling the square root of 16 minus x squared. Well, this comes from the parent function, the square root of x. The square root of x says that the domain x has to be greater than or equal to 0. And then conversely, the range is y greater than or equal to 0. So in something like this, we need 16 minus x squared to be greater than or equal to 0. But that's 4 minus x, 4 plus x, greater than or equal to 0. Which means you have x equaling plus or minus 4. So your greater than or equal to 0 is going to either live between or outside. So if you plugged in 0, 16 minus 0 squared is 16. 16 is in fact greater than or equal to 0. So that means it's true in between. If you plugged in 5, 5 squared is 25. 16 minus 25 is negative. So it's false. So our domain is that it lives between -4 and 4. And again, this graph has no horizontal translations up and down. So that means that this graph still has a range that is positive. It asks you to graph them. Well, if you graphed the square root of 16 minus x squared, you're actually going to get a semicircle. So this is going to give you a circle of radius 4 from -4 to 4. Okay, in 41 and 42, we're looking at function composition. So you guys did 42, let's look at 41. You have f of x equals 1 over x, and g of x equals 1 over the square root. Sorry. So f of g of -1 would become the same as finding g of -1. So g of -1 is 1 over the square root of -1 plus 2. So -1 plus 2 is 1. Square root of 1 is 1. 1 over 1 is 1. So then that's the same as saying f of 1. And f of 1 is 1. So f of g of -1 is 1. G of f of 2 is the same as finding g of f of 2. So f of 2 is 1/2. So this is like finding g of 1/2. So you get 1 over the square root of 1/2 plus 2. So that becomes 1 over the square root of 2.5. which is the same as the square root of 2.5 over 2.5. But we know that we can't have a fraction in a fraction. So 1 over 2.5 is really the same as 2 square roots of 2.5 over 5. Letter C says find f of x. So that's like plugging f of x into f. So it's like getting 1 over x. So we have to get our fraction out of the bottom. So you multiply by x over x, and we get x. And then part D, g of x. So it's like finding g of 1 over the square root of x plus 2. X, yeah. So then you get 1 over the square root of 1 over the square root and that cannot algebraically be simplified. Okay? That brings us down to the next grouping of problems, which is the inverses. So in 53 to 54, you guys had to find the inverse for each function. Then you just show that the inverse was the inverse by taking the composition and getting x. So let's just look at f of x equals 2 minus 3x. So its inverse says that you should flip x and y. Solve for y. So you get y equals negative x thirds plus 2 thirds. And then to verify that they're inverses, you're supposed to do function composition, which means plugging one into the other. And if you get x, you know that they are inverses. So f of f inverse x should equal f inverse f of x, which should equal x. And that proves they're inverses. That is known as the function composition test. X is known as the identity. If we did the reverse of that, we would see it was also true. Okay, I think something like 55 still sorts of gives us troubles. So you have sine inverse of 0.6. So what you should do is on your graphing calculator, type in sine inverse of 0.6. And when you do that, you get 0.6435. So again, that is in radians. It asks you to also find it in degrees. So to convert radians to degrees, you take the radians and multiply it by 180 over pi, because essentially you're canceling the pi's out. And you get 36.8698 degrees. Now 0.6435 is located in quadrant 1. So we know that sine is also positive in quadrant 2. So we could find its reciprocal or second point on 0 to 2 pi. So this is like 0 plus. So to go this way, you have to do pi minus. And we get 2.498. Okay, you could be given the inverse cosine and asked to find all the coordinate points within that match the 6 trig values that we know. So cosine inverse is the same as saying the cosine of the cosine inverse of 3/7 is equal to the cosine of theta. So we get that cosine theta is equal to 3/7, which is how we're used to seeing this. Which means that this is the adjacent and the hypotenuse. It means we need the opposite. So you have to do 7 squared minus 3 squared, and you take the square root of that number, which is 40. So that means that the sine of theta is equal to the square root of 40 over 7. Cosecant would be 7 over square root of 40. Tangent is equal to opposite over adjacent. So it'd be square root of 40 over 3. Cotangent would be 3 over root 40. You were given cosine to start. And then secant would be its reciprocal. Okay. All right, so we also have something like 40, where, give me one. All right, so a good question is something like number 64. It says that if, we're going to call them Joe because Jonita is too much to say. If Joe invests $1,500 in a retirement account that earns 8% compounded annually, how long will it take this single payment to grow to $5,000? So that is looking at our A equals P 1 plus R over N to the NT. So the P is what they started with. So she started with 1,500. We're told that the rate is 8%, which is 0.08 going in for R. Now, N represents the number of compounds. So if it's compounded annually, that's 1. So this becomes 1 to the T as well. Then we're looking to find when A is 5,000. So you have 5,000 equals 1,500 times 1.08 to the T power. So now this is simply a exponential type problem. So we haven't really reviewed a lot of the exponentials. I think like 59 was an exponential, but we need to be able to solve for this. So we have to divide both sides by 1,500. So you get 50 over 15. Oh, my calculator just died. So we get 50 over 15, both divide by 5. So you get 10/3 equals 1.08 to the T. So we have kind of a few choices here. In order to get rid of something to the T power, you can natural log both sides. So if I ln both sides, I get the ln of 10/3 equals the ln of 1.08 to the T. Because a natural log of a number to a power says you can bring the power down in front. So you get the natural log of 10/3 equals T natural log of 1.08. And then we can divide both sides by natural log of 1.08. And that will isolate your T. And then you can go to your graphing calculator, type natural log 10/3 divided by natural log of 1.08. And we get that our final answer, if my calculator would type, it just died, there we go. You get 15.644, and that would be years. Okay. So that kind of summarizes the textbook review. The only thing we really didn't go over, and I believe there are some in your packet, is kind of graphing trig functions. So if you are okay with that, we won't do it. But if you want to go over, maybe graphing another trig function, 1.6, problem number 12. is a great example. So it is y equals 2 sine 4x plus pi plus 3. So we have to look at a couple key pieces of information. The first is the amplitude. The amplitude is the value in front of the sign, so it's a 2. What that means is that changes the range from -1 to 1 to -2 to 2. The period comes from bx, so that's 4x equal to 2 pi, and then solving for x. So what that means is the period is a 1/2 pi. So instead of taking 2 pi to go through one cycle now occurs in 1/2 pi. That means that this is rapidly occurring. It means that it is increasing the number of cycles. So your graph is going to look much skinnier and higher. The domain of a sine function is and always stays all reals. We already kind of touched upon the range and how this changes the range. And then it says to draw your graph. So in order to get our graph, we need to know the horizontal and vertical translation. The horizontal comes from setting 4x plus pi equal to 0, which becomes 4x equals -pi, or x equals -pi fourths. So what that tells me is that this graph shifts left pi fourths. It's also going to change the range again because the vertical translation is up 3. So now my range transforms one last time by adding 3 to each of those. So -2 plus 3 is 1, and 2 plus 3 is 5. So your final range is 1 to 5 because this graph gets shifted up 3 units. So that's kind of like my x-axis now. So sine usually starts at the origin. So now sine is going to start at 3 and -pi fourths. The entire cycle goes from -pi fourths to adding pi halves. So that means that this ends at pi fourths. If you think about sine, it goes up and then back down. So that means that this ends here. The midpoint of -pi fourths and pi fourths would be 0. And then this is kind of like -pi eighths and +pi eighths, because 1/2 of a fourth is an eighth. Our max is 5, our min is 1. So this goes up to 5, down to 1. And then that function would continue infinitely in both directions. In the Sudoku packet, there was a couple parametrics So thinking about that the packet for the Sudoku, you did not need to know how to do some of those problems. And it was just kind of a review handout I had from before. I will send out those answers. So like A, B, C, D, those were all good problems. E, F, G, H, those are all good. It's kind of when you get down a little bit further, like we don't need to know how to do J. You'll need to know, so like again, in that review packet, no J. No O. U. Y. And that's pretty much it. So letter N is coming from our double angle identity. So yesterday on Teams, I sent you guys a trig formula cheat sheet. So if you look at that trig formula cheat sheet for this problem, what you actually want to do is kind of look at the sum to product formula, or no, not the sum to products, the product to sum formula. Because essentially what we're going to do is take the idea that if cosine of x plus pi thirds is equal to the cosine of x times cosine of pi thirds, and then if it's a positive here, it becomes a minus the sine of x sine of pi thirds. And again, that comes from your sum and difference formulas. The 4 is going to tag along because it's kind of like outside all of that. So now you just kind of simply clean this up a little bit, and you get 4 cosine x cosine pi thirds minus 4 sine x sine pi thirds. But the thing is that sine and cosine of pi thirds are on our unit circle. So like the sine of pi thirds is root 3 over 2, and the cosine of pi thirds is a half. So this becomes 4 times a half cosine x minus 4 root 3 over 2 sine x. So 4 times a half is 2 cosine x minus 4 divided by 2 is 2 root 3 sine x. And I believe that's answer 5 for N. You're very welcome. Is that the only one you have from that packet? That's what today is for, answering questions. Alrighty, I should have printed this. Okay, so determine the constant. It kind of is, like once I show you it, you're gonna be like, oh man. So it says determine the constant that would make that true. And to make it a linear factor, it means that you should be able to like pull x minus 3 out. So if you think about like a linear factor, we're going to actually do factor by grouping because there are 4 terms. So you get 3x cubed minus 9x squared plus k x plus minus 12. So that you group and take out your first factors. So you take out a 3x squared. And that leaves you with x minus 3. And then here, what your goal is to make your inside x minus 3 because you want that to be a linear factor. So in order to make that a 3, 12 needs divided by 4. So what that means is if you take out a k, that k that comes out needs to be a 4. Because if you distributed that back in, you'd get 4x minus 12. So that means k is equal to 4, which is option 2. Just kind of think, it's just a little different way of thinking. But that's literally like these questions are what the AP test is a lot more like. So that's why I like this sudoku packet. It's just that this was created back when I had CHS more often and we had parametrics, and AP used to include parametric. So love the packet, just needed to eliminate a couple questions. What else do you need from that packet? Yep. When you made the other side negative, did you make both parts negative? Yeah, so that negative technically distributes to both the 9 and the 6. So that would give you x squared minus 9x minus 22 equals 0. And over here, x squared plus 9x plus 6, which could give you negative 10, equals 0. So then we'd factor them. So you get your negative 10, positive 1. Oops. And then over here, you got 11 and 2. And then you have to go through basically and check them. So we know that like if we plug in negative 10, we're going to get a negative 90. So negative 10 can't be part of my solution set because I can't have an absolute value equaling a negative. And then same with negative 2. So if you plug in negative 2, 9 times negative 2 is negative 18. Well, again, that's going to equal a negative, so we cross out negative 2. So that leaves 11 and 1. Very welcome. Tim, Trevor, questions at all? They both say no. They said you're picking good ones. Or they don't need help at all. Actually, there's only 2 minutes left, so I'll probably wrap it up anyways. There, you're okay. I just realized the bell's gonna ring on us. The answer key to the Sudoku puzzle, like the actual answers, so you could check it, is gonna get posted in a little bit here. I did post the answer key to the chapter review, and then I did odd problems from the chapter review on this video. So you'll be able